Welcome to MP21 TV. I'm Joyce and I'm going to be your host for today. So today, we are going to talk about transition metals. What are transition metals? Transition metals are elements which exist in the D block of the periodic table, which are located in group 3 to group 12 on the periodic table. Transition metals exhibit more than one oxidation state and can interact with a number of negatively charged molecules. During the ancient times, 4 regular transition elements were discovered, namely iron, copper, silver, and gold. The other regular transition metals were only discovered after the early 18th century, with the most recent discovery is rhenium, which in 1925 was detected in platinum ores, and the niobium mineral columbite.
My life.
Hi sir, may you briefly explain more regarding these transition metals?
Alright, transition metals, which can also be defined as an element whose atom has a partially filled D subshell, which can give rise to cations and an incomplete D subshell. Generally, transition metals are any of the various chemical elements that have valence electrons, for example, electrons that can participate in the formation of chemical bonds, as in 2 shells instead of only 1. They occupy the middle portion of the long periods of the periodic table of elements. There are 10 elements in each, with the first series in the periodic form, consisting of elements from scandium up to zinc. Second series includes the elements yttrium to cadmium, and finally the third series extends from lithium to mercury. These 3 main transition series are included in the set of 30 elements, often called the D block transition elements.
High school was never for me.
Miss, would you kindly explain more about the physical properties of transition elements?
As we all know, transition elements are all metals, hence they are hard, malleable, ductile, and are of very high melting and boiling points. By comparing with any main group metals such as alkali metals of group 1 elements, transition metals have higher melting and boiling points. The reason for this is the presence of very strong metallic bonding, which are due to the large number of valence electrons involved in it. Secondly, they have very high electrical conductivity. This is because their electrons are very free to move about within the available vacant d orbitals. Thirdly, transition metals compound are paramagnetic when they have 1 or more ampere d electrons. Paramagnetism is the phenomenon whereby substances are weakly attracted into a magnetic field. Consequently, there is a magnetic moment which results in attraction by a magnetic field. The higher the number of ampere electrons, the greater the paramagnetic properties. For example, cobalt with atomic number of 27 has 3 ampere electrons, while nickel with atomic number of 28 only has 2 ampere electrons. Therefore, cobalt is more paramagnetic compared to nickel. Lastly, transition metals may function in their metallic state or in certain of their compounds as catalysts and are capable of forming alloys with one another and with other elements. Thank you!
Sir, what are the special properties that are possessed by these transition metals?
The chemical properties, or widely known as the special properties of transition elements, comprises of a few special properties. Firstly, transition metals have variable oxidation state, unlike elements in the main group of the periodic table in which each has only one oxidation state. A transition element has more than one oxidation state in its compound. Transition elements can form ions with different charges. This is due to the elements losing electrons from both their 4s and 3d orbitals. Secondly, transition metals form colored compounds. Transition elements can form compounds of different colors, unlike other main group metals compounds which are usually white color. Aqueous solution of transition element compounds or their ions are colored. For example, iron 2 ion depicts a green color substance while iron 3 ion depicts a brown color substance. Besides, transition metals or their compounds have catalytic properties. For example, iron powder is used in the manufacturing of ammonia. Iron catalyzes the reaction between nitrogen and hydrogen gas to produce ammonia. Same goes to nickel in the manufacturing of margarine. Nickel catalyzes the hydrogenation of unsaturated vegetable oil or into saturated oil in the production of margarine. Lastly, transition elements can form complex ion. Complex ion is a polyatomic cation or anion consisting of a central metal atom and surrounded by an array of molecules or anion called ligands. The central metal atom and the ligands are joined together by coordinate bond.
Miss, would you mind telling us the implications of transition metals in our daily life?
Sure, transition metals can be applied to a lot of things in our daily life. For example, titanium. Titanium is commonly used in the production of airplanes, engines, and marine equipment. Titanium alloy is resistant to any corrosion and lightweight. It is also used in orthopedic and dental implants. Titanium dioxide is an important ingredient in white paint. Secondly, iron is alloyed with carbon to make steel, which is used in the making of cars, ships, and building industries. Cosmetics, paints, fertilizers, paper, glass, and plastic also contain iron. Lastly, copper is used as electrical conductors and in piping. It allows electricity to travel through it without significant energy loss. Lightning rods use copper to attract lightning and disperse its charge, preventing it from destroying a structure. Appliances and heating and cooling systems make use of copper as copper is a good heat conductor.
In conclusion, the transition elements have hundreds of responsibilities. They are key elements in life and evolution of mankind. Without iron, oxygen wouldn't make it to the brain and life would not exist. The Bronze, Iron and Steel Ages would never have happened, leaving us in the Stone Age. Transition metals have become of utmost importance due to our ever-growing population and economy. Their demand will continue as long as life as we know it continues. So that's all for today, and until next time, bye!
My life